Okay, so let's get into this. We're doing a deep dive today into a really critical vulnerability in some of the most advanced AI.
Right. We're talking about multimodal large language models, or MLLMs.
And specifically, their inability to really, trust what they see. Researchers are calling it visual ungrounded hallucinations.
It all boils down to a fundamental bias, really. These models rely so heavily on their language priors.
So all the common sense they learned from reading, like billions of web pages.
Exactly. And that knowledge often overrides what they're actually seeing in a video, especially if that video shows something, well, something impossible.
And the source material had a perfect example of this. It's kind of amazing, actually. You show one of these top-tier models a video. In the video, there's a girl standing on a small pile of rocks, and then suddenly the pile just grows, like it triples in size out of nowhere.
And a standard MLLM, even a really powerful one like GPT-4o, just ignores it. It defaults to common sense and says something like, the pile of rocks remains the same throughout the video.
Its brain knows rocks don't do that.
Right. But the new system we're looking at today, it gives the visually correct answer. It says, the rocks multiply and grow into a much larger pile. It trusted its eyes.
That failure to see the impossible is what we're tackling. So how do you force an AI to see something it believes can't happen? I mean, do you just show it more impossible things?
That's precisely the idea. The core problem is that these impossible videos are just so scarce in the real world. So the solution was to manufacture them.
To create them from scratch.
Yeah, using a framework called DualityForge. It uses these controllable diffusion-based video editing tools to just generate tons of high-quality counterfactual data.
So they're building this huge library of unreality. What kind of impossible stuff are we talking about here?
They broke it down into 3 levels to really challenge the model systematically. You've got your basic visual anomalies.
What about pixel glitches, that sort of thing?
The distortions. Then you have semantic anomalies, where maybe an object just vanishes or gets swapped with something else. But the real challenge is the third category, common sense anomalies. This is where you get videos that just completely break the laws of physics.
And that's the real test, isn't it? Because an MLLM's internal textbook says lava cools and flows a certain way.
Right.
So if you show it a video where a lava stream just vanishes into thin air, it trusts the textbook, not the video.
Exactly. So DualityForge was used to create this massive data set called DualityVidQA. It's about 144,000 samples, all built on paired videos.
Paired, meaning you have the original normal video
and the edited impossible version. And you ask the model the same question about both. It has to give different answers, which forces it to ground its logic in the visual evidence, not its prior knowledge.
So that gets us to the training itself. The data is one thing, but making the model learn is another. It's called a DNA-Train.
Duality normalized advantage training.
Yeah.
It's a 2-stage process. After some initial fine-tuning, it moves into a really critical reinforcement learning stage.
And what's special about that?
Well, it solves a balance problem. For an AI, normal real-world videos are easy. They generate a really strong, clear learning signal.
They fit the pattern it already knows.
But the counterfactual videos, the impossible ones, are much harder to process. And if you just train on both equally, the easy data just kind of dominates the process. The learning becomes unstable.
So you need a way to make the AI pay just as much attention to the hard stuff.
Precisely. They introduced this normalization technique that, in simple terms, acts like a dimmer switch. It turns down the learning impact of the easy, real videos.
Which forces the model to put equal effort into understanding the tricky, physics-defying ones.
It's it. And the results really back it up. This whole approach led to a 24% relative improvement in mitigating these hallucinations.
24%! That is a huge leap in making these systems more trustworthy, and it didn't just fix that one problem, right?
No, it also boosted performance on general video understanding tasks. So this isn't just a niche fix, it makes the model better overall. It's critical for things like robotics or verifying images.
So what's the big takeaway here then?
I mean, it seems that sometimes the most effective way to get an AI to genuinely understand our reality is to challenge it with a very robust, very well-crafted, synthetic unreality.
By showing it things that can't happen, it learns to better see the things that do.
Yeah, and it really makes you wonder if we can fix this kind of deep-seated cognitive bias by showing an AI something impossible, what other weaknesses could we patch in the same way? Okay, let's unpack this. This is a massive announcement from CES 2026. Today we're diving deep into NVIDIA's very public ambition. They want to become the Android of generalist robotics.
Exactly. They're not just selling chips anymore. They're building the entire default platform for what they call physical AI.
Feels like a huge industry pivot.
It is. I mean, for years, AI was stuck in the cloud, just crunching data. But now, with cheaper sensors and these, incredible simulation tools, AI is finally moving into physical machines.
The machines that can actually think in the real world.
And act in the real world. That's the key.
Which gets to the heart of it, right? Moving beyond those very narrow, task-specific bots, the ones that can only do one thing well.
To something completely different, generalist robotics. We're talking about machines that can reason, plan, adapt, just, like a person does.
But how do you even start to build a brain that capable?
Well, it all starts with their software ecosystem.
Yep.
And at the foundation, they've released new open models right on Hugging Face.
Okay, so what's the first piece?
The first key piece is Cosmos Reason 2. It's a reasoning vision language model, a VLM. This is what gives the robot its senses. It lets the AI literally see, understand the context of what it's seeing, and then figure out what to do.
So Reason 2 is the core perception engine, the brain, basically. Why do they need a second model, then, this Isaac GR00T and 1.6?
Okay, so GR00T is the vision language action model. It's specifically for humanoids. If Cosmos Reason 2 is the brain that sees and plans,
then GR00T is the body control, the muscle memory.
that's a perfect way to put it. It provides the sophisticated coordination for whole body control. It's how the robot moves and handles objects at the same time, all based on what Reason 2 is telling it.
Okay, so you have the brain, but the brain needs a place to practice, a gym. And that's where these world models come in, right? Cosmos Transfer 2.5 and Predict 2.5.
Exactly. This is all about solving the biggest, most expensive problem in robotics: validation. Physically training a robot on a complex task like pouring a drink is so slow, it's expensive. You break things.
So the world models generate synthetic data to avoid that.
Tons of it. They generate vast amounts of realistic data, which then feeds into the simulation environment, Isaac Labarina.
And Labarina is where it all comes together. It's their open source framework on GitHub. It feels brilliant because it standardizes everything. It pulls in industry benchmarks, Libero, RoboCasa, RoboTwin, into one place.
Right, so for the first time, developers aren't wasting all this time building their own training rigs. They're all working off a single, unified standard.
And what's the connective tissue holding all that together?
That would be NVIDIA Osmo. It's the open source command center that integrates that whole workflow. From the data generation to the simulation to the final training, it just works across your desktop or the cloud.
And you need some serious hardware to power all this efficiently on the actual device.
You do. And that's the role of the new Blackwell-powered Jetson T4000 graphics card. It's the newest in the Thor family. It packs, get this, 1,200 teraflops of AI compute.
Wow. 1,200. And how much memory?
64 gigabytes. And the amazing part is it runs at just 40 to 70 watts. That's the kind of efficient edge compute that makes this whole thing viable for, mass adoption.
Which is why the accessibility push through Hugging Face is so smart.
It's totally strategic.
Yeah.
By putting Isaac and GR00T into Hugging Face's Lee Robot framework, NVIDIA instantly connects its 2 million developers with Hugging Face's, 13 million AI builders?
So for you, the listener, you don't need specialized robotics knowledge anymore just to start experimenting.
Not at all. You can just grab these models and test them. Say, on the open source Reachy 2 humanoid running on that new Jetson chip, it just massively expands the user base.
And it seems like it's already working. The market is validating it.
It is. Robotics is now the fastest growing category on Hugging Face. And you have big names already adopting the stack: Boston Dynamics, Caterpillar, Franka Robots, NUR Ray Robotics.
It confirms the strategy. They're not competing with robot makers. They're becoming the underlying OS, the default.
The default operating system for physical AI. That's the goal.
It's a remarkable pivot. So looking ahead, what's the big takeaway here?
I think it raises a really provocative question for you to think about. If these incredibly complex capabilities of physical AI seeing, understanding, acting, if they're all becoming standardized and open source, what new everyday tasks are we going to see robots doing in, say, the next 5 years?
In our homes or factories?
Everywhere. The shift from specialist to generalist is happening right now, and it's accelerating much faster than people think.
Okay, so let's just dive right in. If you're trying to set up an enterprise AI factory, you always hit the same critical wall. How do you move fast? Training huge models, deploying at scale, without just opening up a massive security hole.
Right, because these factories are a prime target, a hacker's dream.
Exactly. And that's what we're digging into today. NVIDIA's expanded enterprise AI factory design and specifically how their BlueField tech tries to solve this tension.
That's the mission. It's not just about faster chips. It's a whole new way of thinking about the infrastructure. We need to see how it secures that entire AI pipeline.
So let's start there. This is where it gets really interesting for me. What exactly is NVIDIA BlueField?
So you can think of BlueField as the dedicated processor that powers the operating system of the AI factory.
The operating system.
Yeah, its job is pure logistics. It's accelerating all the essential services, networking, storage, orchestration, and of course, security.
Okay, but I have to ask, adding another specialized processor, doesn't that just add complexity or cost?
Yeah.
What's the immediate return on that?
It's all about consistency. Think of your GPUs, your very expensive GPUs, as world-class sprinters.
Okay.
Well, if you make those sprinters also answer the phone and file their own taxes, they're going to run slower. BlueField is that dedicated logistics team. It handles all that other stuff, freeing up the CPUs and GPUs to do one thing: focus 100% on the AI workload.
So it's about separation of duties at the hardware level.
Exactly. That prevents the bottlenecks and lets you scale with consistent performance.
That makes perfect sense.
Yeah.
So let's talk security, because the sources really hammer this idea of defense operating at the same speed as AI.
Right.
That sounds ambitious. How does this dedicated hardware deliver something like zero trust at that kind of velocity?
Well, it works because it pushes all of those security functions entirely off the main compute. It isolates them.
So security isn't a tax on the system anymore?
Precisely. And the key piece of software making that possible is the NVIDIA DOCA Argus framework.
Argus. Yeah, okay, so when we hear that term, zero trust AI runtime protection, what does that actually mean for a security team on the ground?
It means security is no longer just bolted on at the perimeter. It's a native hardware function of the AI processor itself. Argus is like having a tiny, super fast security camera inside the processing core.
Wow.
It gives you this incredibly deep visibility across all the riskiest stages: data ingestion, fine-tuning, inference, all in real time.
So security is embedded from the ground up.
I like that.
Now that we get the how, let's talk about the who. Who's actually leveraging this on the NVIDIA RTX PRO servers?
Yeah, so we can basically group the partners into a few key functions. First, you have zero trust enforcement.
Okay.
That's where you see Checkpoint's Infinity AI Cloud Protect and Fortinet extending its security fabric.
And Palo Alto Networks, I saw, with Prisma Airs.
Yep. They all plug into that same Argus telemetry to enforce policy.
So that's the real-time enforcement. What about just managing and orchestrating the whole thing, especially for multi-tenant setups?
A huge piece of the puzzle. For those really sensitive, regulated environments, Spectra Cloud's Palette AI Secure is now validated.
Right.
And then for orchestration, you've got Redfay and Red Hat OpenShift, making sure different AI jobs stay completely isolated from each other.
And the last piece, you need eyes on everything. The policy and monitoring.
Correct. And that's where Trend Vision 1 comes in. It basically combines that real-time telemetry straight from BlueField with global threat intelligence. You get a complete picture.
It all seems to connect back to this idea of a stronger, integrated foundation. You're not just buying parts, you're buying a pre-tested system.
A system designed to minimize risk and maximize throughput at the same time.
Right. A foundation where dedicated processors handle all that complexity, security, networking, letting the AI models just run unimpeded.
Which is the whole point.
Yeah.
Now, here's a final thought to chew on. Armis-Centrix is now also validated on this.
And they do continuous cyber exposure management.
Across AI factories of any size. So consider this. What does true continuous infrastructure protection actually look like when security is integrated at the processor level from day one, constantly assessing risk, instead of just reacting to threats after they happen?
That's a different world entirely.
It really is. That's the question worth mulling over.
So when we talk about AI, we usually think about models that can, see and then label things. But what happens when that AI moves beyond just labeling and starts to actually think inside our physical world? That's what we're digging into today. NVIDIA Cosmos Reason 2.
Yeah, and that's the core mission, 100%. I mean, current vision language models, VLMs,
Right.
They're great at seeing a pattern, but they're kind of blind to basic physics, to common sense. They really struggle when they have to plan, 5 or 6 steps ahead to get something done.
Right.
Cosmos Reason 2 is built to close that exact gap, and our sources are clear. It's now the top open model for this stuff on the physical AI bench leaderboards.
But if a VLM can already see patterns, why do you need a whole separate model for common sense? How does it How does it actually get a robot to see, understand, and then plan and act?
Well, the insight is pretty crucial. It's not just about recognizing a wrench. It's about understanding that a wrench acts on the world. With leverage, with torque, it gets there by integrating actual knowledge of physics, of inertia, of how things have worked before. It's modeling things dynamically, not just taking a static snapshot.
To do that kind of methodical modeling, you must need a massive context window to, keep a long plan in your head.
Ah,
The sources mention a jump to 256K input tokens.
that's a huge leap.
That sounds massive.
Yep.
What does that actually allow for?
Yeah, from the old 16K limit, it's a total game changer. That context lets the model watch a much longer video clip and connect events that are far apart.
Mm.
So you get real long-term planning without it forgetting what it was trying to do in the first place.
It's not just a longer memory.
No, it's paired with spatial precision. CR2 now gets 2D and 3D point localization, bounding boxes, all that critical trajectory data.
So the physical world is being mapped with coordinates, not just words. And they added OCR support, optical character recognition.
Yes.
What does that unlock?
It connects what the model sees to readable text that's right there in the video. So think about a video analytics agent.
Okay.
It's analyzing footage of a rainstorm. It doesn't have to guess the speed limit. It can just read the street sign. Salesforce is already using this with their Cobalt robots and the VSS blueprint to make workplaces safer.
And the autonomous vehicle space. I saw the proof of concept there is really strong too. Uber is looking at this for generating video captions for AV training.
The data there is genuinely impressive. You see two key metrics just jump. BLEU scores, which measure accuracy, they went up by 10.6%.
And that's a big deal.
It is. And Lingo QA, which is more about the overall quality and coherence of the text, that went up by 13.8%. So the captions aren't just accurate, they're actually useful for a human who has to review them.
Beyond just captioning, though, the core of it is the robot planning and reasoning itself. It's the brain.
It is the brain, yeah. It's providing not just the next step, but the exact trajectory coordinates for a physical task.
Like that example with the painter's tape.
Exactly. The robot moving painter's tape into a basket. CR2 plans the whole step-by-step path for the gripper. It knows how to avoid hitting other things. It's the difference between a robot just flailing around and one performing a methodical, predictable action.
So how does this fit into the bigger picture, the whole NVIDIA ecosystem?
CR2 is the reasoning layer. It plugs right into other key pieces. You have Cosmos Predict 2.5, which can actually generate a video of what it thinks will happen next, up to 30 seconds into the future.
Mm-hmm.
And crucially, all this reasoning feeds directly into models like NVIDIA's GR00T and 1.6.
The big humanoid robot model.
The VLA model built for humanoid robots, yeah.
CR2 gives GR0T the foresight it needs to control its whole body in a really complex space.
So the big takeaway is physical AI is here. It's capable of complex, forward-looking action, all because of these huge leaps in reasoning. It is, and that leaves you with a pretty big question to think about, right? If AI models can now consistently predict complex physical movements, like Cosmos Predict suggests, what new ethical or even logistical challenges pop up when our tech gains real physical foresight into our world? It's something to chew on. You can actually start exploring it yourself with the Cosmos Cookbook recipes online.